Welcome back to Advanced Skills Learning. GenAI prototypes are easy. Production systems are hard. Today's topic is uncomfortable, but critical. Not every problem needs an LLM. In fact, using one in the wrong place can increase cost, reduce accuracy, and slow your system down. The real skill is not knowing where to use LLMs. It's knowing where not to use them. And in production systems, this single decision, where you apply LLMs, often determines whether your system scales or fails. Many teams fall into the same trap. If LLMs can solve complex problems, they start using them everywhere: classification, routing, validation, even simple lookups. But LLMs are probabilistic systems. They are slower, more expensive, and less predictable than traditional code. So when you use them where determinism is required, you're not adding intelligence. You're adding risk. The best engineers don't ask, "Can I use an LLM here?" They ask, "Should I?" If your problem can be solved with clear rules, you should not use an LLM. Think validations, thresholds, routing rules, or structured decisions. A simple if-else block will always be faster, cheaper, and perfectly consistent. LLMs, on the other hand, may interpret rules differently each time. And that variability becomes a production liability. If your logic can be written as rules, introducing an LLM only adds unnecessary uncertainty to a deterministic problem. If your system requires exact answers, LLMs are the wrong tool. For example, what is the account balance? Or, what is the policy ID? These are not reasoning tasks. They are retrieval tasks. A database query guarantees correctness. An LLM might paraphrase, approximate, or even hallucinate. And in enterprise systems, almost correct is unacceptable. Whenever correctness is non-negotiable, always prioritize systems that guarantee exact results over probabilistic outputs. Quick check. 2 seconds. Which should not use an LLM? A. Fraud rules. B. Essay generation. C. Email summarization. Keep your guess. The answer is A. Fraud rules are deterministic and require strict consistency. LLMs are not built for high throughput, low latency workloads. If your system handles thousands of requests per second, adding an LLM can become a bottleneck. Each call introduces network latency, compute cost, and variability. For real-time systems like monitoring, trading, or API routing, traditional systems are far more reliable. Use LLMs where latency is acceptable, not critical. At scale, even small latency per request compounds into major performance bottlenecks. In regulated environments, consistency and auditability are essential. Think healthcare, finance, or legal decisions. LLMs cannot guarantee the same output for the same input every time. And that makes auditing difficult. If you cannot explain or reproduce a decision reliably, you should not let an LLM make it. If a decision must be audited later, it must also be reproducible today. If your task is structured transformation, like JSON to JSON mapping, LLMs are overkill. Traditional code ensures schema correctness, validation, and consistency. LLMs may introduce formatting errors or unexpected variations, and then you end up writing more code to fix the LLM output, which defeats the purpose entirely. If you need to validate or enforce schema, code will always outperform an LLM in reliability. Quick check. 2 seconds. What is the best tool for JSON mapping? A. LLM. B. Rule engine. C. VectorDB. Keep your guess. The answer is B. Rule engines ensure deterministic, schema-safe transformations. LLMs are expensive compared to traditional compute. If your task is simple and frequent, like keyword matching or filtering, using an LLM will multiply your costs. At scale, even small inefficiencies become massive bills. So always ask, is the intelligence worth the cost? If not, stick to simpler methods. Cost efficiency is not just about model size, it's about choosing the right tool for each step. Security systems require strict, predictable behavior. Think authentication, authorization, or access control. LLMs can be influenced by prompt injection or ambiguous inputs. That makes them risky in security-critical paths. Never let a probabilistic model decide who gets access to your system. Security systems demand zero ambiguity, which is the opposite of how LLMs operate. The correct way to think about LLMs is this: they are a reasoning layer, not your default layer. First, use deterministic systems for rules, databases for retrieval, and pipelines for structure. Then use LLMs only where ambiguity, language understanding, or reasoning is required. That's how real systems scale. Think of LLMs as the final layer in your architecture, not the foundation. Let's recap. Do not use LLMs for deterministic logic, exact retrieval, high-scale systems, compliance-heavy decisions, structured transformations, cost-sensitive workloads, or security-critical paths. LLMs are powerful, but only when used in the right place. Good architecture is not about adding AI everywhere. It's about knowing where AI belongs. Strong systems are built by combining deterministic components with intelligent layers, not replacing everything with AI. If you want to build GenAI systems that actually work, not just demos, this series is for you. Subscribe to Advanced Skills Learning for practical architectures, real-world trade-offs, and quick quizzes to test your understanding.